Our next speaker is Jin Pan. Jin is a senior at MIT studying computer science with an interest in reliable and scalable systems. He enjoys working on high-leverage software projects and has previously worked on building smart sales tools such as Counsel Genomics, high-frequency trading strategies, and natural language query processing for private data at Argo Technologies. During his time at Gunn, Jin was involved in math circles, competed in the Science Olympiad, and wrote his first line of code in the AP Computer Science class. Jin.
Hi. So I'm Jin. I graduated Gunn, 3 years ago, and studying computer science at MIT. And today I'm going to tell you a story of how a finance group at MIT that I'm involved with fought for our autonomy through software. So at a high level, I'm going to introduce what trading simulations are and what Traders MIT, a student group, does, and our conflicts of a large monopoly. Then I'll briefly describe our solution and talk about the engineering challenges and resolutions we had along the way. These are experiences really common to a lot of engineering projects. I'm really excited to share a story. So first off, what are trading simulation games? So they're games where you just try and buy low and sell high. Alternatively, short sell low and short sell high and then buy low. And they're on synthetic data, and this data is fed to you in real time. So you're not biased by hindsight, where you can easily pick out highs and pick out lows. And through these, you can rapidly teach how markets work. You get really fast feedback on exactly what you're doing right and what you're doing wrong, namely through how much money you're making or losing. And through these trading simulations, you can actually teach pretty big transferable lessons to all parts of life, even if you're not considering a financial career. You learn a lot about statistics along the way, about how to choose features for machine learning. You got to see how a lot of Wall Street gurus are actually wrong, and a lot of them are just spouting gibberish. So it sounds great. What's the catch, you might ask? So the problem with this is that there's actually just a single organization making this simulation platform. And as history has shown, monopolies like to abuse their power, and we're actually on the other side of this abuse lately. So I'm going to switch gears a bit and talk about Traders MIT. We're an undergraduate club, pretty small, about 10, 15 people, it depends on the year, composed of some math majors, some physics majors, finance majors, computer science majors, and even one mechie major lately. And the big thing we do is host an annual fall trading competition. So we invite about 100 students from top finance schools, Wharton, Columbia, NYU, Harvard, and the like. And they all compete, come to MIT, and play a role in this trading simulation game. And we use this Monopoly simulation supplier. And we had really good relationships with them initially. But within that monopoly, their leadership changed a few years ago. And now they're giving us pretty undesirable terms. They're restricting how big our competition can get. And they're demanding thousands of dollars just to use their software. And so a couple of people within Traders decided we don't like getting screwed by Monopoly. And we noticed that there's a really low barrier to software entry today. There's a huge number of open source projects, and there's a huge number of very talented people in technology, which make developing software really easy. So I got together with some other people and decided, hey, let's just write our own trading simulator. We called it Mango Core. If you want to know why, talk to me after. We want to mimic the market as realistically as possible, which means you have to make a reasonably complicated thing. So you have to have an exchange which accepts orders and matches them together, account management to track what people actually bought, what they're holding on to, how much risk they're holding on to, and how susceptible they are to volatility. You also have to design a user interface for non-technical people to place their orders. And you also want to design an API for technical people to write automated strategies. You want to have internal traders within your platform providing liquidity in the markets just to make the simulation interesting. You need to provide internal tooling for other non-technical members of your organization so you can design interesting cases that actually show off what markets are like. You also have to write a router to get all the packets sent to the right place. It's a bit more than your standard project. And so I'm going to talk about some of the challenges we faced and some of the resolutions we had. So challenges. So we weren't a startup by any means. We're just a student group. And as such, you're not exactly recruited to build Mango Core. You're recruited because you're interested in finance and you have a mix of, let's say, quantitative or computer science or financial backgrounds. And it's actually really hard to involve everyone. On top of that, because you're a student group, you have a mix of age ranges. You have seniors that are basically checked out and want to do as little work as possible. You have freshmen who don't really know that much going in, and you have to kind of involve everyone's strengths in a unique way. And the way that we did that was we all just kind of got together and helped build each other up. When you have someone really strong in math, but they might not know computer science, you match them up with someone who's good in computer science, and you just pair people's strengths up. You also want to match freshmen with upperclassmen mentors, just get them up to speed. It's really important to not just focus on your product, but you also want to focus on building your team up and keeping them engaged. A huge factor in success of a project is how well your team operates and how well they can cooperate together. On top of that, in a lot of class projects, 90% is an A, which is good enough. Maybe 95 if you want like not an A minus. Or even 60% at MIT will get you an A sometimes. We have some hard classes. But in our case, 90% availability isn't good enough, right? If you have 100 people competing and 10 people can't connect, that's pretty bad. And even 99%, that's like an A plus. Doesn't work for us. We have 100 people competing, one person gets burned. Really sours our reputation, and we much rather just pay $1,000 to keep our good reputation. And so we have to design a very robust product as well and support all the features we mentioned earlier. And in this pretty interesting journey, I encountered some qualities that really stuck out to me as good qualities to have in engineering, in an engineering role. So one really effective engineering property is how some people take ownership in their features. They treat it as if it was their baby. They really want to see it succeed. They want to see it written really well, and they want to see it stand the test of time. And they take care and design things and put a lot of thought into it. They also obsess about complexity. It's really easy to go out and just write something without regard to the rest of your code base and just get it working. But that just doesn't fly for us because we have huge amounts of turnover every year. About a quarter of the club graduates, and we just basically lose them. And so you have to have a very easy to understand, easy to maintain code base, and it really helps if you obsess about complexity and really fight to minimize the amount of complexity you have. Another really strong property is how effective engineers are able to understand the context of what they're working on. A lot of projects, especially those that involve startups, everyone's really busy and nothing is fully specified. And in order to make the best possible decision, you really have to know what's the bigger picture and how do my small little changes and small little decisions that I make impact things on the big scale. And another thing is the show must go on. Competition is at a certain date. We can't just have a feature just lagging if it's critical. And so, some people get blindsided by midterms, get sick, and some really strong people just pick up the slack and make sure the show goes on no matter what. Found those to be really strong qualities in a team. And at the end of the day, we now have kind of a trading simulation duopoly. There's that existing monopoly who had a strong product, and we've actually shipped version 0.1. We had a small little competition within MIT, and it worked really well, really smoothly, and we're probably going to roll it out soon. And so we effectively bought our, or fought for our autonomy through writing this big software project. It was really cool. And as side effects, our group traders at MIT amassed quite a bit of street cred. We're able to attract some of the best engineering talent at MIT to come and work with us. So we have a very strong freshman class as a result of this project. And as for me, it really helped me land my internship at Google Loon. When I was interviewing, I noticed after I applied that the position was only for PhD students. I'm undergrad. And when I asked my manager why I got it, he said, I was really impressed with this trading simulation you led, and that effectively satisfied the PhD requirement. That was really cool. And if there's one kind of takeaway lesson I got, is that when life gives you a challenge, you should accept it with a big challenge accepted, and just do cool things, and more cool things will follow. Thank you.